Welcome back to another episode of Study Time on the Active Recall YouTube channel. And today we're going to be talking about how masks and classes divide IP addresses into three parts. Now, this is taking us down the rabbit hole of subnetting even further because we're going to talk about how masks and classes come together to further complicate subnetting. We're going to be talking about how classes of IP addresses influence the way that we analyze our IP addresses and how we analyze the network that these IP addresses belong to. Let's just hop right into it. So, as per our last video, we know that subnet masks divide IP addresses into two parts, right? It divides it into the network part and the host part. Now, as per an example that we have here, we can take IP addresses such as 172.16.1.1 with the slash mask of 24 and know that the network is part of 172.16.1 and that the host part is 1, right? So we can use an example here, right? If we have 172.16.1.1 with a slash mask of 24, we know that the network part is going to be 172.16.1 and the host part is going to be 1, right? But what happens when we use class rules or we acknowledge class rules when looking at IP addresses or trying to just analyze the network in general? First of all, let's review what class rules are real quick, right? So class rules basically define the magnitude of the network parts and the host parts in bits. And the network bits as it pertains to each class is locked. That means that they don't change for any reason at all whatsoever. We'll see that this starts to matter more and more down the line when it comes to subnetting and setting up our subnets. But for now, we're just gonna stick to simple examples that illustrate the influence of class rules. So we know that class A IP addresses are from 1 to 126 and it has a default mask of 255.0.0.0, right? And class B ranges from 128 to 191. This is the first octet we're talking about here. I forgot to mention that. And the default mask is going to be 255.255.0.0. And class C, the first octet, starts with 192 to 223. And class C ranges from 192 to 223. And the default mask is going to be 255.255.255.0, right? So we can just shorten it up. And as per our last lesson, let's just use our slash mask format, right? A slash mask or prefix format notations. /16, and this is /24, right? We got to get some practice in with these conversions, if you will. Now, when we add the complexity, let me stop playing. When we add the class rules layer, we can break the network part into two parts, the network part and the subnet part, right? So we have, again, as per the class rules, this fixed bit setup depending on which class the IP address is in, right? Now, don't confuse the network part with the network bits. They're two different things. So the network part is, we're basically just talking about the subnet ID, or in better terms, let's talk about it in terms of, you know, because I don't want to jump ahead too far, but we're talking about the network ID, right? We're talking about where that default mask identifies or indicates the network part of the IP address, which excludes the host part, right? So if we have 172.16.1.1/24, remember we're using our slash mask, that /24 right here it's 255.255.255.0. I like using the slash mask more and more nowadays because it's easy to just indicate it, right? Without writing out all these freaking numbers, right? So if we have 172.16.1.1 with a subnet mask of 255.255.255.0, we know that this is a class B address, right? So this right here, this is a class B, right? And we can't really we can't really know that based off of the subnet mask that we have here, but we know that because the first octet falls within this range right here, right? So we know, we can see, okay, it's a class B, it's a class B address, but we know as per our IPv4 video that this indicates that it's a class B private IP address, right? Again, we have 172.16.1.1 with a slash mask or subnet mask of 24, or in DDN 255.255.255.0, right? We know that since it's a class B private address or class B address, the network bits are locked at 16 bits, which means that 8 bits is left for the subnet, right? This is pretty straightforward. It's easy to understand. So the network part is a total of 24 bits as indicated by the slash mask, right? We're gonna illustrate this with the binary mask, which I hate writing out, which is why I'm glad I prepared this wonderful work of art, that study notes that will save us some time and not having to write everything out, right? So in other words, the network part consists of network bits and subnet bits totaling 24 bits. Remember, when we're dealing with IP addresses and when we're dealing with subnetting, we're dealing in terms of bits, right? You're gonna see where bits come in somewhere down the line when we're designing our subnets, right? And we're gonna have to particularly get real good at using our base 2 exponents and a host of other addition, subtraction, and a little multiplication, right? So let's use our dreaded binary format to illustrate this point of how important bits are when it comes to dividing this IP address up into 3 parts, 3 important parts, that is. So we have, again, our same example, 172.16.1.1/24, right? And we know that N, which is our network bits, is 16, right? So we know that our network part of our IP address is 24 bits, right? That means 24 bits are turned on in our network part of the IP address. Now watch right here. We see that with this octet, right? 8 bits, 8 bits, and 8 bits. But since we know that N is equal to 16 and this is locked, that means that there's 8 bits left over, right? 16 minus 8 gives you 8. Voila, magic, right? So now we have 8 subnet bits in the network part of our IP address and 16 locked bits in our IP address, totaling 24 bits, right? And we know host bits are left over and our host bits total up to 8 bits, right? And look how beautifully we can illustrate this right here, right? This is why we did our conversions and formatting, different forms of formatting when it comes to our subnet mask in the last video, because they really help us to identify the different parts of the IP address in tandem with other information such as the classes of the IP address, right? So let's use another example, right? And this time we're going to be using a class A IP address. So we have 10.1.1.8/24, right? And that is a class A IP address, because guess what? This 10 falls between 1 and 126, right? That's our first octet, right? And we see that, yeah, we see that right here. That's a class A IP address. So what does that mean? Since it's a class A IP address, we can already tell off the bat without even looking at anything else that it has 8 bits, because we know, because of our nice little default mask right here, default mask, we have 8 bits turned on, right? And that's the default. That's just the way it is, right? So now we have another simple example. If we have 10.1.1.8/24, we can see that when we apply class rules, we'll have the network part equal n equal 8 bits plus 16 bits for the subnet, right? And why is it 16 bits for the subnet? Oops, I'm moving stuff around. We have 16 bits for the subnet because, again, our mask, which is /24, tells us that we have this, right? And we're doing a little conversion work right here, right? 255.255.255.0, right? And let's convert that to binary, which we have right here, right? Beautiful, beautiful illustration we have here. Oh, I love Microsoft Whiteboard. So now we see easily, we can tell with our nice little drawing, courtesy of Wendell Odom's CCNA official cert guide. It's a great book. I love the way he explains it. We have 8 bits right here turned on for the class A indication of the IP address, right? And we know that, like I said, we know that right off the bat because this right here is between 1 and 126, and it has a default mask of /8, 8 bits turned on, right? That's how we got that N right there. Now, what's the rest, right? We see that we have this left, or we see that we have these 16 bits left over, these 16 bits that are not part of N, if you will, and that means that it is the subnet. It's the subnet bits, right? So that is, as we can see, 16 bits. That's where our subnet is at. And of course, what we have left over is 8 bits for host. So that's pretty much it. It's pretty straightforward. And this is more so the mathematical, practical preparation for subnetting, right? I don't really go too much into like the history and the analogies and stuff like that because I don't want to confuse myself and I definitely don't want to confuse you guys. But this is straightforward stuff compared to how complicated it may or may not get as we move along when we're talking about subnetting, right? So let's look at the summary real quick. We know that subnet masks divide an IP address into 2 parts, the network part and the host part, right? But then we can zero in to the network part for the simple fact that with subnetting, we're interested in the network part. Of course, we're interested in the whole IP address. We're interested in everything we can know about the IP address and the network that it belongs to, but we zero in to the network part to analyze it to see where the subnet is at, right? See where the network bits are, and then we can use that information to analyze the network. And we can, as you see here, we're reverse engineering some examples like this right here to understand the nature of subnetting with regards to the IPv4 anatomy, right? We analyze the network part of the IP address by using information about the class that the IP address itself belongs to, right? So we can break the network part into network bits and subnet bits. Now remember, the network part is different from the network bits. The terminology is kind of confusing, but this is how I'm learning it. We talk about IP addresses in the terms of the subnet mask and the way that it divides IP addresses into the network part and the host part. But then, as I stated before, the network part consists of two parts in of itself: the network bits, right? The network bits, which is defined by the class of the IP address that it's in. Class of IP, right? So if it's like we have in the example, so if we have the first octet and let's use one of the examples, yeah, the 172, right? We know that that's class B, so we automatically know that the network bits is going to be 16 as indicated by its default mask, and its default mask is /16. Means 16 bits are locked in for that network, right? And of course, we know that if we have a subnet mask, not the default mask, if we have a subnet mask that we're given, we can ultimately figure out how many subnet bits there are, right? And therefore, we have the IP address broken up into 3 parts, right? So we learned that IP addresses could be divided into 3 parts via mask and classes of IP addresses. So that's pretty much it. I'm really proud of myself. I got through that video in in a reasonable amount of time. I'm trying to make these videos a little bit more palatable. I'm trying to be more structured with it and creating these notes and everything. And somewhere down the line, if anybody's interested in these notes, I'm just gonna bunch them all together and throw them into like a Dropbox or some type of Google Docs or some type of cloud sharing situation to share these study time notes with you guys. We're studying for the exam. We're trying to pass this exam. And although it's great to know the ins and outs, the history of IP addresses and subnet masks and stuff like that, I think that this is one portion of the exam that requires that you really know the math and know the math well and get familiar with the math well so that you can get through these questions as quick as possible. I'm more so concerned with locking in on the practical methods for us to solve these problems as quickly as possible. And you're gonna see more of that as we move forward in this study time series that covers subnetting. But if you would like to check out the last video we did where we was talking about subnet mask, click this video right here, and I'll talk to you guys next time.